Hello students. So today we are going to start the first chapter of mathematics, that is sets. Now how do we define a set? Right? Generally the very common conception of a set is we can place any element in the brackets or the collection of objects is called a set. Like if I write spoon, chair, pen. So do you think we can call it a set? Spoon, chair and pen. So though it is a collection of objects, but still it is not called a set. The proper definition of a set is a meaningful collection of objects. A meaningful collection of objects is called a set. Now, how can we make this set meaningful? Now, this set has three different objects which have no relation to each other, right? So, what we can do is we can make a set of the elements of similar kind. Like if we are taking a spoon, what similar items can we have? We can make a glass here. These are utensils or cutlery that we use in a kitchen. Glass, plate, knife. So now they have some kind of similarity between their usage or their placements. So this is a set, a meaningful collection of objects. Why we are calling it a meaningful collection? Because we can relate it with the common property that we have to see. The second thing is, like if we take another element like chair, we can make another set of the similar items like chair, table, cupboard, bed. Now we can say that they have a common property that we can call them, they are elements of furniture, right? And the third one, like I used here, it is a pen. So pen, pencil, ruler, eraser. How can we combine the properties? Now these are the objects which are used as stationary items, right? Now we can say that all of these three collection of objects form a particular set, as we can denote them by a little bit of combination or a common property that we can combine them. So this is how we define a set. A set is a meaningful collection of objects, right? So now you can see that sets are generally written as this is a presentation. We always use capital letters to denote set, these curly brackets, and then we write these elements by putting commas. Why I'm telling you this? Because the next thing is how we write a set or represent a set. Presentation of a set. Like I told you, if I write a set by writing the elements in a curly bracket, like if I write 1, 2, 3. Now this form, when we write elements by putting commas in between them, this is called the roster form. This is one kind of presentation of a set, which is roster form. And the other is called the set builder form. Set builder form, right? Now, any set can be written in both the ways. Here you will realize the reason why we have a meaningful collection, because we need to know what is the property which is combining these elements. So how can we say that? These are the numbers starting from 1. 1, 2, 3, 4, 5. So you very well know that the numbers starting with 1 are called natural numbers, right? So in a set builder form, we set builder, as the name denotes, we write the property by which the elements of this set are linked to each other. So the presentation we do it is this way. X is such that X is what? Now here we have to mention the property. So how can we relate them? These are natural numbers which are less than or equal to 5, right? So X is such that here we have three things to denote. First of all, it is X belongs to natural number. First of all, we have to tell what kind of number we are dealing with. There are different sets like rational numbers, integers, natural numbers, whole numbers. So first of all, the set has to be informed what property they have, whether they are whole numbers or integers. So here they are natural numbers. Now, natural numbers are infinite, we know. So since it is a finite set, there are countable elements here. We have to write the limit also. We can say 1 is less than x is less than equal to 5. That means the numbers we have defined here in this set are between, or you can say including 1 and 5, less than equal to 5. And here, whether we mention 1 or not, that is not important, as we know when we have mentioned natural numbers. So natural numbers start with 1, right? So this is the second way we can express this set. So if we have to write set builder into roster form or roster into set builder form, we should know how to link this and how to write this. Let us take one another example. Let us B is, now I'm doing X is such that X square minus 25 is equal to 0. X belongs to R, right? Now we have to look for, this is already in the set builder form because here the presentation is given in the definition of the set builder form. We have to convert it into roster form. How can we do that? The set says the answers are in the form of real numbers. That means what are real numbers? It can be a positive, negative, fraction, root, right? So it can be any number. It can be in decimals, roots, square roots, cube roots. Now we have to solve this equation to find the answers to this set. What is that? X square minus 25 is equal to 0. So when we factorize this, we get this equation. Now solving this, we get x is negative 5 and x is positive 5, right? So this is a quadratic equation. So we will be having two roots here. You got these two roots? Now this was a set builder form. This was the property or the link between the elements. Now when we have to write it in the roster form, then we can write it as negative 5 and positive 5. Right? So this is the corresponding roster form of the set B. Right? So let me take one. Give me. So let me take another example, which is easy one. When it comes to a set like X is such that X is a letter of word algebra. Now, when we have this kind of question, to write it in the roster form. See, this is a set builder form. This gives us the definition of the set. Now, when we write the elements by putting commas, that means we have to write the letters of this word. Now, you can see, when we have repetitive elements in a set, we should write it once only. These are the few things that you should remember. First of all, the order of the elements does not matter. Thing is, next thing, we are supposed to write like A is in repetition. So we will be writing it only once. A, E, B, G, L, R, right? So order doesn't matter and repetition should not be used here in the sets, right? These are the few things that you need to take care while converting set builder to roster or roster to set builder form. Okay. Now, let us come to another topic, which is types of sets. Types of sets. Okay. So now, types of sets. First of all, we have empty set. Now, how can a set be an empty set, right? Empty set, or we can call it a null set or void set. All of them mean the same thing, right? Empty set, null set, or void set. Now, how can one set be a null set? Null set is a set which has no elements. So I can give you one example in set builder form, right? See, a set, like if I write x is such that x square is equal to -2 and x belongs to R. Now tell me, x is a real number. In till class 10, you have learned about real numbers, that all the numbers which are rational, irrational, rational, irrational, till irrational. So if this is a set of real numbers, this is rational, this is irrational. Though they are disjoint sets, we will learn it later how to present them. But real only contains rational and irrational. Have you ever heard of a number whose square is a negative number? We haven't done such things till class 10, right? So there are no real numbers for which this equation can be solved. X square, we have learned that square of a number can never be a negative number, right? So when we try to find solution to this set, it is not possible. So when we write solution to this set, this is phi. Phi represents null set. Or you can do it this way also. See, be careful. Never write curly brackets and phi in between. This is not a null set. This becomes a singleton set. Because either you have to make curly brackets and there is no element inside which shows void set or null set, right? Otherwise, you can make a symbol of phi, which represents null set. When we are making null set, we are not supposed to put brackets around this phi. Either use this symbol or this symbol. So such brackets, such sets where we have no solutions to particular given condition, they are called null set, right? The next kind of set is singleton set. Singleton set. As the name denotes, singleton means a set having only one element, right? So, like if I write x is such that x plus 2 is equal to 0 and x belongs to R. Now there is a set whose solution or elements are the solution of this equation. So we can solve it like x plus 2 is 0 and x is equal to -2. This is -2. This is the only solution for this equation. And you can see it satisfies the condition that it is a real number. X belongs to R. That means x is a real number. So yes, it is. So now we have got only one answer to this question or this relation. So this kind of set, which has only one element, this is called singleton set. Or you can write few other examples also. If it is 1 or only A, see, I can make this like this on 5 when written inside this curly bracket. This is a singleton set. So never make a mistake here by calling this a null set. Here 5 is being treated as the element of the set, right? If we want to write void set, it is only 5. Singleton set having only one element. Next we have finite set. Finite, as the name denotes, a set having countable number of elements. A set having countable number of elements. Like if I write A as 5, 10, 15, 20, 25, and then I put it the bracket inside the bracket. Now you can see here we can count 1, 2, 3, 4, 5. There are 5 elements in this set. So it is countable. That is why it is called a finite set. Right? I can write this set in the set builder form. Now you can see what is the property which is linking these elements. All of them are multiples of 5. X is such that X is equal to 5 times N. What is N here? N is a multiple, like 5 times 1, 5 times 2, 5 times 3. So N are the numbers by which we are multiplying 5 to get these numbers. And since we are starting with 1 here, so N is a number from natural numbers, right? So when we are writing finite sets, we have to write all these things. I told you in an earlier example also, you have to mention the set from where these numbers are being taken. This is the link or relation between the elements. Now, in case of finite sets, you have to find the limit of the set. Limit means what is the last element here? It is the 5th multiple. So if I go for the value of N here, it is 5. To get 25, we have multiplied 5 by 5. So the value of small n here is, we start with 1 here, 1, 2, 3. So n, value of n is moving from 1 to 5. So we have to put the limit like n is less than equal to 5. Since it is a natural number, we know that it will be starting with 1. We need not mention it, right? But the last number has to be put as a limit. That is up to 5th multiple we are writing here. So it is a finite set, right? If I write 2, 5, or you can say 1, 2, 5, 10. 1, 2, 5, 10. This is the roster form. This corresponding set builder form of this set is X is such that X is a positive factor of 10, right? I have mentioned it in the language. Positive means we are not supposed to write negative number, -1, -2, -5, positive factors of 10. So these are the examples of finite set. Next is infinite set. Infinite set. We can convert these sets into infinite, like a set having uncountable number. As we know, natural numbers, whole numbers, all of them are uncountable. Set having uncountable number of elements, right? So, like we had taken there 5, 10, 15, 20, 25. After that, I can put dots here. What does this mean? This means you can extend this set up to infinity, we have infinite multiples of 5. So there is no limit to the last value. This kind of set is called infinite set, right? So how can we modify this in the set builder form? X is such that X is equal to 5n and X belongs to n. 5n, sorry, n belongs to n. N belongs to n. But we had written here, n is less than equal to 5 because we had the last element known to us. Here, there is no last element known, so we have to end our set description here. So X is 5n and n belongs to n. Since there is no limit to the natural numbers, we have no limit to the multiples of 5 here. So such kind of sets are called infinite sets, right? Next we have equivalent sets. Equivalent sets. Now before defining equivalent sets, I would like to give one definition: cardinal number. Cardinal number, right? Cardinal number is the number of elements in a set, right? So if I write A as 1, 2, 3, that means n of A is 3. This is how we write cardinal number, right? Number of elements in set A is 3 here, right? So this is the cardinal number. Cardinal number of A is 3. If I write B as 1, 2, 3, 4, 5. So number of elements in B or cardinal number of B is 5. So this n of B means number of elements. Don't get confused in this n with n of natural numbers, right? This is n of A, n of B. Cardinal number of the sets. Now what are equivalent sets? Equivalent sets. Sets having same cardinal number. Same cardinal number only, right? We are not talking about elements here. It's only cardinal number. So if I write A as A, B, C, set P as 1, 2, 3. What is n of A? N of A is 3. Number of elements in set A. Number of elements in set P is also 3, right? So we can say A is equivalent to B. Here we only have to consider the number of elements, right? So these are equivalent sets. And finally, we have equal sets. Equal sets. Now, this is exactly when a set is an equivalent set, and moreover, the elements are also same. Equivalent sets having same elements. Equivalent already denotes that the sets have the same number of elements. They are already equivalent. Now, if we make the elements equal, like A is these 3 elements, and set P becomes R, U, P. I had told you in the beginning, the order of elements does not matter here, right? And even if they are written in different order, these two sets are exactly equal. Set A is equal to set P, right? These are equal sets. So these were different types of sets. I hope you liked watching this video. If you have any kind of query or you want to take classes, please do contact Urban Pro for this. Thank you for watching this. Thank you.